Hi, I'm Peter Haddock and I'm here with Richard at Komatsu UK headquarters here where they make this machine, the PC210 and some others. But Richard, we last spoke about smart construction at FutureWorks.
We did, yes.
There's no intelligent machine control stickers on this machine. Why have you brought me here and why have I got a Samsung tablet in my hand right now?
The intelligent machine control is built here in KUK.
Yeah.
But in this case, what we're doing here this week is we're looking at our new retrofit kit that we've developed for smart construction, which is a 3D machine guidance system, but also a data feed into the smart construction dashboard, so we can look at the as-built data, etc. So this machine here, which is our demonstration machine from the demo ground here, standard PC210 LC-11, has been fitted with the smart construction retrofit kit.
We talked about making data but information available to people through smart construction. So you've got a lot of fleet of Komatsu machines and other OEM machines
brands, yes,
that you can actually retrofit with this technology that makes, folks, smart construction possible right now. So fundamentally it's machine guidance as well. It's not machine control.
Yeah.
So there's a lower price point for people to enter into that. But also, when you've got a Komatsu machine or when you've got other machines connected with Intelligent 2.0, as they say, they can work with this machine and the retrofit to send information to your smart construction platform, can't they?
Absolutely, yes. Yeah, and the part of the message is that the retrofit kit complements the intelligent machine control, because the intelligent machine control has that control element. This is guidance, so it's at, as you said, a lower level, but it is 3D machine guidance with 2D also. But it's the dual purpose. It's providing that guidance for the operator to help with the efficiency on the job site, but also giving us the data feed from this machine directly to smart construction. We can see the as-built data, we can understand what's going on the machine, we can communicate with the machine, and essentially use this machine as one of the Internet of Things sensors on the job site to feed information to us.
When you've got an asset giving you real-time information, and when you've got that connected into a system with all the other fleet and equipment on site, you can actually start to measure the progress of what you're doing on a daily basis and on, in some cases, a real-time basis.
Yeah.
But what's interesting about this is there's a bit of an added extra to it, because you've got payload monitoring as well.
Absolutely.
So we're going to actually see this digging and loading the new Komatsu ADT. But fundamentally, what it allows us to do is say, look, this is the work you've done, but this is the muck you've shifted, this is where we've taken it to, and therefore you're building up that picture of your cut, your fill, and your material movements, which is critical, isn't it?
Yeah, it is critical. I mean, what smart construction is all about, using these kind of tools to answer pains for the customer. And the pain may be simply how much material has this machine shifted in a shift, or it may be what's the terrain it's created, or how can I help the operator work more efficiently. So the retrofit kit can answer a number of those pain points, but it also then can add value in that we can take the data stream from this machine and create extra information that the customer perhaps doesn't even realise they need at this point in time, but in the next job they might do, in the future they might do. So it's about increasing the digital sensing on the job site, the level of digitization that exists on the job site, in order to answer more concerns, answer the problems that the customer might have, and do it in a very cost-effective way with their existing equipment. As you said, it's brand agnostic, it's not just Komatsu. The only thing that's different between putting it on a Komatsu machine and on another brand is, on the Komatsu machine we can do the payload functionality.
Which I like,
We don't do that on other brands because we don't want to be breaking into their hydraulics. We're confident on our machines, but not on others. So that's something we've got to remember. But the machine then becomes not only a more efficient machine, but it's got the very good value machine guidance built in, but it is fundamentally becomes a data feed into our digital ecosystem to answer those questions.
And also you've got other things like fleet from your smart construction portfolio that allows us to measure the health of the machine and also the activity and fuel burn and things like that. So that can all calculate together to give you useful information to say, actually, am I making a profit on this job? How can I do it better? But equally, how can I show the client, particularly more and more clients now, the information they want from us?
Yes, and I think it's important to understand that the data feed doesn't actually have the value. The value comes from the information you create.
Yeah.
And in a lot of cases, the information is needed from more than one source. The data feed from this machine alone has some use, but complement that with the movement of the machines with fleet, so where the dump trucks are, how many dump trucks have interacted with this machine, for example, or the terrain data from drone flights or from as-built from other machines or from surveys. Suddenly, that metadata where you're bringing different streams together actually gives you real value in terms of the information, the reporting, which is then answering those customers' questions. So it's important to think that no one machine or one data feed can answer questions without complementary data from other sources, and that's very, very important.
What I like about this though is, look, this is a different kind of tablet, folks. This is just a standard Samsung tablet here.
Yep.
I can put this into that machine, so I don't have to have a specialist tablet or anything like that. Again, if I want to have a fleet of this connected machine assets like this with the retrofit system, I can actually have different tablets.
The way that we've designed the system is the connectivity between what is effectively the human-machine interface, the HMI, and the system itself is through Wi-Fi connection to the tablet.
Right.
So we can put a rugged mount in, we have a rugged tablet, you download the app is there. When we issue updates, which happen frequently, they automatically update, same as it does on your phone or your tablet at home. Very easy, very portable. Also an advantage is it works out here. So if the operator's got a problem, as long as we're in Wi-Fi range, we can actually see what's going on. We can help the operator.
Yeah, absolutely.
Very flexible, very simple, very easy to use. And that's one of the overriding factors in all the technology we're developing and implementing is it's customer focused. It's got to be simple. It's got to be easy for them to use. A low cost of entry and a low ease of entry into using the technology.
So let's go and have a look at some of the fundamentals of the retrofit, and let's start with the brains inside, shall we?
So on this particular installation, we've actually installed the controller, which is the main brains of the kit, if you like.
Right in there.
Tucked away, maybe difficult to make out, but tucked away in here. That's the controller.
Yep.
That's connected in this case to a SATEL radio, so we're getting our correction data from our base station here at the factory via SATEL radio feeding into the controller. Tucked away, out of sight, behind the lock covers.
Yeah.
Apart from noticing the antennas and the installation on the boom and arm, you wouldn't know this machine has this system installed. See on the handrails?
Yep.
Standard kind of GNS antenna mount, multi-system GNSS working on all of the possible satellite constellations. So that's the core of the system in terms of understanding where it is in global positioning terms. What we then need to do is we need the machine to understand where it is in terms of roll, pitch and yaw and the geometry of the work equipment. So in this area here we've got the IMU sensor for the 3D machine guidance system. This gives you the body of the machine, the roll, position, yaw here. And then tapped into the boom foot, the base of the boom cylinders, we have networked hydraulic sensors. They're measuring the pressure in these cylinders, which we use then to calculate the load in the bucket.
Right.
After calibration. It's a dynamic load system, so you don't need to pause, let it measure. As you're slewing to do a load or to transfer the muck, it's measuring the weight in the bucket during that swing.
So then obviously as we go further down the boom, we've got more sensors.
Yeah, so the same style of sensor, the IMU sensor that we have fitted to the revolving frame, we also install on the boom, the arm and the bucket links.
The only way you're going to benefit from a digital connected worksite is getting connected, folks. And now you can do it even simpler with the team, Richard at Smart Construction and the Komatsu team here. If you need a demo, you can come along and say hello to them at the demo area where we are right now.
Yeah.
Cheers.
Thank you.